So we're on topic 7 and applying Desmos, and it's to the page 34. So this is the last video on topic 7. We're going to do problem number 23 on page 34 using Desmos. And you can see here we're given the value of a car as a function of years after purchase. We're given two ordered pairs, an X and a Y value, and here is another X and a Y value. And what are we asked to do? Find the linear equation for the depreciation. Depreciation means the value of the car is going down with time. So the longer you own the car, the less the value is. So here is the value. The value, as you see as you go along, is going down. And this is the years after purchase. So assuming that the equation is a straight line, you're asked to find the equation. You're asked to find the original price. What is the value of the car 8 years after purchase? And in how many years will the car have no value? So first of all, what we're going to do is put in the years as X1 and X2. So you'll see that we are given the ordered pairs. The values of X are 3 and 5, and the values of Y here are here and here. So we're going to first of all start with the values of X and then put the values of Y in. We're going to call X sub 1, X sub 2, Y1, Y2. So one set of ordered pairs on the line, let's say 3 and 10,000 is my X1, Y1, and 5 and 7,500 is my X2, Y2. So here's the formula for the slope. I calculate the difference in the Y's over the difference in the X's, and you can see the slope is negative minus 1,250. So I know the value of M. Then I calculate B by putting an ordered pair in here, Y2, X2, and using the M. I could say B equals Y1 minus M X1. It'll give me the same value. And the value of B is 13,750, which of course is the y-intercept, and it's right over here. If I click on this point, I get the y-intercept. You can put this on projection mode, and if I click over here, I get 11, 0, which means essentially that it takes 11 years for the value of the car to go to 0. So once I've got the value of M and B, I can just put in Y equals MX plus B, and this straight line indicates that it draws this line in as the graph, as the linear expression of what's going on. And then if we want to know the value of the car after 8 years, instead of X here, right here, we put an 8. So it uses the M, multiplies it by 8, and adds B, which is right over here, and the value after 8 years is $3,750. And so we have all the information. Let's go back. We'll find the linear equation for the depreciation. We found that. Y equals MX plus B. We solved what was M and B. What was the original price of the car? That's right here at time 0, 13,750. What was the value of the car 8 years after purchase? We put X equal to 8 in, and we showed the value right here. So it'll be 3,750. And part D of the question said, how long will it take for the car to depreciate to 0? Don't forget, this is the y-axis. The value of the car is going down. So here, Y is 0, and the X is 11, which means it takes 11 years for the value of the car to go to 0. Okay, let's look at a problem that is sort of a made-up problem. It's not really part of the manual, but it shows some interesting points. And supposing we were given the points that lie on a line and we were asked to identify what the equation of the line was. In other words, we need y equals mx plus b, so we need the value of m and b. Let's assume that the points are 1, 6, 0, 9, 2, 3, and minus 1, 12. And there's entered here, 1, 6, 0, 9, 2, 3, and minus 1, 12. So these points are the 4 points that are shown here. We've connected, we click on here, and we show the points and connect them. So this is the line right here for the 4 points given. We then put in a generalized equation where the object here is to fit this line, get this line to fit this line. And we're going to do that by changing m and b. Now, initially, it doesn't matter. You put in the slider for m and you put in the slider for b. Don't worry about these values here. It doesn't matter what they are initially. What you say, well, why is this 6.62? That's just a number that I chose. Y is m equal to 1. Okay, so right now, this line here is y equals x plus 6.62 because the slope is 1, and you can see that it goes through roughly at 6.62. That's the y-intercept. So this is the point. These are the 4 points lying on the line, and we want to get this line here to match this line to match this one by changing m and b. The first thing we do is, you see the intercept here is at 9, at y equal to 9. So what I'm going to do is change the value of b to 9 right here. It's the first thing I'm going to do, change the value of b to 9. So I've done that. Now the line runs through this point right here, and it has to. So that's one of the requirements. Now what do I do? All I do is I change the value of m. I use the slider to change the value of m until the 2 lines match. You see, here are the 4 points. Now I've got the line matching. I got that by changing m equal to minus 3. So the equation of the line that I'm looking for that fits these 4 points is minus 3x plus 9. Now, one of the things I know about this line is that the slope is negative. Okay, we've done this before. This slope is negative, so I have to choose a negative slope. But even if you don't know that, just once you've got the intercept, you change the value of m until the 2 lines coincide. Okay, here. So this is really the extension of y equals mx plus b when m is minus 3 and b is 9. So the equation of the line that fits these 4 points is y equals minus 3x plus 9. Now when x is 0, minus 3x is 0, and I get plus 9, which is this. Let's just check another point. When x is 2, we get minus 6 plus 9, y is 3. So 2 and 3. So that's just another way that we can look at a problem. And what I've tried to show is, once I've given these 4 points, or I'm given any sets of points, as long as there's more than 1, I can derive an equation that will fit that line. So that completes topic 7 and the applications to